Welcome back to our channel of YouTube, where we want to make vectors simpler for everyone. Now in the last video we looked at how we can get the point of intersection of lines, and in this video we want to go for the angle in between lines, and this one will be the last chapter about lines. Then we shall go for planes first, then we go for lines and planes. We shall go for a bit of planes, how we get the equation of a plane, then we will go for lines and plane like that, and we conclude by plane, distance between plane, a point from a plane, such of that. Now what we want to know is the angle in between lines. Now if we have two lines like this, the line, this is line 1, it will always have a direction vector, and this direction vector we call it B1. If we have another line, this is line 2, it also contain a direction vector moving along with it, and this one will be a B2. Now the angle in between these two lines, line 1 and line 2, which we call theta, we shall see that it is also the angle in between these two direction vectors B1 and B2. The angle might be this, the angle might be this, angle might be this one, or angle might be this one, anything. The answer will be okay, it will be one value, and we said we use what we call the dot product. Now in the dot product we said that if we have any vector A, then times any vector B will be equal to the absolute of vector A times the absolute of vector B, and we said that's the cosine of the angle in between those two vectors. Now here we shall have lines L1 and the L2 with direction vectors B1 and B2. Here it will be a B1 times a B2 will be equal to the absolute of B1 times the absolute of B2, then the cos of theta. Why are we not taking line points? Line points are not vectors. Now we can take line points that we shall dot the point A and B. We just take the direction vectors. Now a point to note is that for any lines to intersect, if lines intersect, they have to be with the angle. There must be the angle between their point of intersection. And if we borrow from the previous number we have just solved, and we have proved that the lines intersect, whichever thing they will give you, the lines will be intersecting. Now for our case, we proved that for these lines, x over 1 is equaling to the y plus 2 over 2 is the same as z minus 5 over negative 1, and the x minus 1 over negative 1 is equaling to y plus 3 over minus 3, and z minus 4 over a 1. Previously we show that we have shown that these lines do intersect. Now I want to get the angle between these two lines. What I need is to get from line 1 and the line 2, just I need of the direction vectors B1. B1 will be these values down, which will be a 1, 2 and negative 1. Then B2 will be these values down if this one is positive and they are starting values. If these are positive and are starting values x, y and z, this will be negative 1, minus 3 and 1. Then if I have that, I will go for let the angle be theta. Then I will say that a B1 dot a B2 will be equal to absolute of B1 dot the absolute of B2, the cos of theta. Then I will go for now dotting. I'm going to substitute into this formula at once, then I get the answer, I leave the stuff. Now B1 is this one, I'll have 1, 2, negative 1, then dot a negative 1, negative 3 and 1 is equal to absolute of B1. Now absolute is square root of those individual numbers squared. Now this one will be 1 squared plus 2 squared plus negative 1 squared times the square root of negative 1 squared plus minus 3 squared plus 1 squared, then the cos of theta. This one is multiplied with this n. Just say that the sheet of paper is too small. You will forgive me and you will bear with me that things sometimes don't work as we want. Now I want to solve this. Now I'll go for 1 times a negative 1 will be a negative 1 plus. 2 times a negative 3, it will be a negative 6 plus. Negative 1 times a 1 will be a minus 1. This will be equaling to the absolute. 1 squared is 1. 2 squared is what? Is 4. Negative 1 squared is 1. Then times negative 1 squared is 1 plus negative 3 squared is 9 plus 1 squared is 1. Then the cos of what? Theta. Now negative 1, negative 6 and negative 1, this one will give you something like negative 8 will be equaling to the root. Now 4 plus 1 plus 1, that is 6. Then times the root, and this one will be 11. Then the cos of theta. Then from there I can multiply this and this, get negative 8 is the same as the root of 66. Then the cos of what? Theta. Now meaning cos theta will be minus 8 over the root of 66. Then from there I need the theta will be the cos arc of negative 8 over the root of 66. Here don't place into a calculator. Don't say that now the side angle, the other one we could do in trigonometry. No, this is math. Just place as it is. These are vectors, then you'll be getting the answer. Even if it is positive or negative, you'll be just noting the answer. I want you to do that and note for me which answer shall we obtain at that point. Thank you for following. Let me see whether I can look for any other, or else I will send you numbers and you try out and you see whether things can work as we expect them to work. Thank you for your time, and keep subscribing those who have not subscribed, so that you can be informed about anything new. Thank you.